Ya, Assalamualaikum warahmatullahi wabarakatuh and hello everyone. So kita akan continue our lecture to chapter 7 which is thermal expansion of matter. Okay, so pada chapter 6 kita dah belajar tentang elasticity of a body of a object, right? So now kita nak belajar thermal expansion of matter. Okay, so bagaimana sesuatu objek tu berubah terhadap temperature. Okay, so uh, so first kita tengok dulu which is what is temperature. Okay, so we know that temperature is measure of how hot or cold of something or an object, right? So and then the thermometer is the instrument that we use to measure the temperature. So in order to reduce, they take advantage of some property of matter that change with temperature. Okay, so we measure the temperature by using the thermometer. So that's the two different term between temperature and thermometer. Okay, so temperature we can measure by using either Fahrenheit, Kelvin or Celsius scale. Okay, so usually we use in Celsius. Okay, so there is some temperature scale that you know when you have some value of temperature. For example, you have the value of temperature in terms of Celsius, and then sometimes you need to convert it into Fahrenheit. So how you want to convert from Celsius to Fahrenheit, from Celsius to Kelvin, so on. Okay, so you know that the freezing point of water is 0 degree, and in the Fahrenheit scale it's a 32 Fahrenheit, in Kelvin scale is 273.15 Kelvin, and the boiling water of water is 100 degree Celsius. In Fahrenheit is 212 Fahrenheit, and in Kelvin 373.15 Kelvin. Okay, so you have the reference point or reference level of temperature, which is freezing point and boiling water. So then you can calculate or you can make a conversion between Fahrenheit, Kelvin or Celsius. Okay, so for example, you want to convert from Celsius to Fahrenheit. So Celsius to Fahrenheit you can calculate by using temperature of Fahrenheit is equal to 9/5 temperature in terms of Celsius plus 32. So and then you will get the value of Fahrenheit temperature. Okay, so for Fahrenheit to Celsius you can calculate by using 5/9 temperature of in terms of Fahrenheit minus 32, and then you will get the temperature in Celsius scale. Okay, for Fahrenheit to Kelvin, so Fahrenheit to Kelvin is equal to 5/9 temperature of in terms of Fahrenheit minus 32 plus 273.15, and then you will get temperature in Kelvin. Okay, so Celsius to Kelvin, temperature in Celsius plus 273.15. So I believe that you remember this one, right? So just the temperature of Celsius plus 273.15. That's how you want to convert the temperature in Celsius to Kelvin. Okay, so maybe you can try this one at home to convert from Fahrenheit to Celsius, Celsius to Fahrenheit, and Celsius to Kelvin. So there is an answer below. So check your answer with the answer given. Okay, so now we want to look what is the thermal expansion. Okay, when we use or we talk about the thermal is actually it's about the temperature, the change in temperature, how the body reacts with the temperature, either it cools or the temperature will increase. So that's about the thermal. When we talk about thermal, you refer to the temperature. Okay, so a substance will expand when heated. Okay, so means that when we give a temperature for a substance, the temperature will be increased. Okay, so the temperature will be decreased or cool when the substance will contract when it is cool. So means that the temperature will be decreased. Okay, so different substance exhibit different amounts of expansion and contraction, consists of linear expansion, area expansion, or volume expansion. So means that bila ada different material ataupun metal, okay, object, so dia akan react different expansion. Either dia akan linear expansion ataupun dia akan berlaku perubahan pada permukaan ataupun volume. Okay, so for linear expansion, okay, so for almost all solid, the change in length is directly proportional to the change in temperature as well as the original length of an object. So, bila ada berlaku perubahan temperature or we give them increase the temperature, okay, so akan ada berlaku perubahan panjang bagi sesuatu objek, which is perubahan panjang tu selalunya adalah directly proportional kepada temperature, okay, which is when your temperature is increased, the length will be also increased. Okay, so from this equation actually we get the equation of L minus L naught, which is L is the new length, L naught is the original length, is equal to alpha L naught delta T. Okay, when we make a L as a main equation, we become L naught plus alpha L naught delta T. And then factorize L naught, you will get 1 plus alpha delta T. So that's the equation for here, which is L is equal to L naught 1 plus alpha delta T. Okay, so you can calculate the final length when you have a increase of temperature by using this equation. L, which is the new length, L naught is the original length, alpha, what is alpha? Alpha is the coefficient of linear expansion, okay, and delta T is the temperature difference. Alright. Okay, so the unit for alpha is degree Celsius negative. Okay, so the final length of a after change temperature, so this is the final length or the new length of a material. Okay, so yeah, I think this one is directly equation, the equation that you can understand, right? So the second one you can look is the area of expansion. Okay, so some object will be changed in their area also. Okay, for example, two-dimension object or plate. Okay, so when they have an increase in length, they usually will increase their surface area. Okay. So I want to show you the equation. Okay, so let me open on Jamboard first. Where is the Jamboard? Okay, so for area expansion, for example, you have an area of square. The original length is L naught, right? So L naught. So when you have a change of length, usually it will change of their surface area. Okay. So for example, change. So this one will also change. So this one is delta L, this one is delta L. Okay, clear? Okay. Now, we know that the area is L naught times L naught. This is the original area. So you will get L naught square. Okay. So the new area, when there is change in length, you will get A is equal to L naught plus delta L, right? So this is the new length. L naught plus dengan delta L. So because the area is panjang darab lebar. Okay. L naught we can also write like this one. Alright. So times this one. Okay, you will get L naught square plus L naught delta L plus L naught delta L plus delta L square, or L naught square plus 2 L naught delta S plus delta L square. Alright. So this one you can ignore because it's approximately is equal to 0. Okay. So you know that L naught square is equal to A naught. So just replace A naught plus 2 L naught delta L. Okay. So 2 L naught delta L. Alright, so from linear equation, you know that delta L is equal to alpha L naught delta T, right? So you can substitute this equation into this equation. So you get A naught plus 2 L naught alpha L naught delta T. So 2 L naught square delta T. So this one is equal to A naught. A naught plus 2 A naught delta T. So factorize A naught, you will get 1 plus 2 delta T. So where's my alpha? I'm missing my alpha. So this one alpha. Alright, so you get 1 plus 2 alpha delta T. So that's right. Okay. So you can calculate the new area of an object by using this equation. A is equal to A naught 1 plus 2 alpha delta T. Okay. For length, previously L is equal to L naught 1 plus alpha 1 plus alpha 1 plus alpha delta T. Okay. So you can take this one, 2 alpha is equal to beta. So this one rewrite, you can get A sama dengan A naught 1 plus beta delta T. Alright, clear? Okay, so back to the equation. So I think I already explained that one. Okay, and simplifying, we get A is equal to A naught 1 plus 2 gamma alpha delta T. Change of A divided by A naught, you get 2A 2 alpha delta T. So if you change this one, you get into beta. Okay, you get delta A is equal to beta A delta T. So that's the equation for area expansion. Okay, how about the volume expansion? Okay, so for volume, so when you give the volume change of temperature, you also change of volume, absolutely. Okay, so I will show you how to prove the equation for volume. Okay, for example, you have an object with the side of L0. So this is the cube, right? So the initial volume is equal to L0 cube. Okay, so the new volume will be L0 plus dengan delta L. So maybe there will be change of length, so there will be change of volume. Okay, so by using expansion, you will get L0 cube plus square delta L plus 3 L0 delta L plus delta L cube. So these two equations you can ignore because it's approximately equal to 0. So you know that L0 3 is equal to V0, right? So V0 plus 3LO square delta L. So just substitute this equation with the equation of linear expansion. So you get alpha L0 delta T. So substitute. So this one is equal to V0 delta T. So we get subfactorize 1 plus 3. This one alpha. Get alpha delta T. Okay. So this is the equation. You can calculate the final volume when there is some change of volume when you give change of temperature. Okay, so this one I already proved the equation. So you can simplify using this equation. Delta V divided by V is equal to 3 alpha delta T. So 3 alpha actually is equal to gamma. So you can substitute this one. So delta V over V0 is equal to gamma delta T. So the coefficient of volume expansion is defined by gamma is equal to delta V times delta T. Okay, clear? Okay, the length of copper wire is 20 degree is 40.5. So 20 degree adalah 4.5 meter. Dia nak cari new length when temperature is 95. New temperature is 95. What is the length at 95? Given alpha. So just use equation L is equal to L0. 1 plus alpha delta T. So everything is there. So you get the new length is 4.50. Okay, a piece of copper metal has an area of 500 centimeter square. So this is the original area at 0. So means that 0 degree Celsius 500 centimeter. So calculate the new area at 80 degree Celsius. So what is the new area? Okay, so you know that A is equal to A0 1 plus 2 alpha delta T. Okay, so this one is given. So this one you can take from this one. Delta T is 80 degree. 80 minus 0 is 80. So the new area is 501.36 times 10 power of negative 4 meter square. Okay, the third example, calculate the increase in volume of 100 centimeter cube mercury. So the original volume is 100 centimeter cube and temperature change from 10 degree to 35 degree. So delta T is equal to 25 degree. So given gamma is equal 1.6 times 10 power negative 5. So they want to calculate the increase in volume, means that delta V. So we know that delta V over V naught is equal to gamma delta T. So you get delta V. Alright, so this is the exercise 9.2. Please try at home. Okay. For example, number 1, metal rod. So this is the original length, L naught. This is the T1, T2. So delta T is equal to 20 degree. So this is the final length, L. So what is the coefficient? So they ask the value of alpha. Second one, this is the side. So this is the value of L. So T1 sama dengan 20 degree. T2 is equal to 180 degree. So means that delta T 160 degree. Change in length. So dia nak delta L. New surface area. Dia nak new surface area. Given that alpha. This is the value of alpha. So please try yourself at home. Okay, and then the number 3 is determine the change in volume of a block of cast iron. So this is the volume of original. So the temperature change from 15 to 47. So calculate the delta T. So this is the alpha. Alright. So please find the change in volume delta V. Alright. Alright, so we want to look at the gas law. Just a simple one. Okay, gas law, we have 4 types of gas law. I will not go into details of this law. Okay, so we know that Boyle's law. Okay, at Boyle's law, the temperature is constant. If the temperature is constant, you can use the equation of P1 V1 is equal to P2 V2. Okay, that's obey the Boyle's law. Okay, for Charles' law, the pressure is constant. So the equation for Charles' law is V1 over T1 is equal to V2 over T2. And then how about the pressure law? At the pressure law, V is constant. So P1 over T1 is equal to P2 over T2. And for other gas law, we know that P1 V1 over T1 is equal to P2 V2 over T2. Okay, so how you want to use? Okay, so many of you ask me how you want to use, what law you need to use. Alright, so you first you need to know what is constant in that equation, either temperature, pressure or volume. So if you know what the constant in that equation, so that so that you can apply the law that's suitable for that equation. Okay, at low density, real gas obey the relationship PV is equal to nRT. P is the absolute pressure in Pascal, V is the volume, N is the number of mole. What about R? R is the gas constant and T is temperature in Kelvin. Okay, so you need to know the Avogadro number. So you know that the Avogadro number is equal to 6.02 times 10 power of 23. Okay, you know that PV is equal to nRT, right? Okay, so N is the number of mole. It actually can write as N over NA. The number of moles divided the number of Avogadro number, RT. Alright, so R over NA is equal to Boltzmann constant. So you can actually use KBT. So that's the another equation. Okay, for example, a rubber balloon is filled with helium gas at 1.05 tons. So this is the pressure to a volume 0.3. So this is the volume. And then the balloon is let off and it rises up. So ni P2, ni P1. Okay, so they ask the volume, final volume. There is no change in temperature. Okay, but then when we have no change in temperature, we know that it's about the Boyle's law. Boyle's law state that P1 V1 is equal to P2 V2. So V2 we can calculate P1 V1 divided by P2. Alright? So you get the final volume is 0.603. Okay. The second one, an ideal gas at 20 degree T1 and pressure volume V. So they given T, PV. So the number of moles. So they ask the value of N. And then they give R. So we know that PV is equal to nRT. So N is equal to PV divided by RT. Alright. So you get the value of number of moles is equal to 6.16 10 to the power of negative 2. Alright. So that's all for this lecture. So if you have anything to ask, you can ask me directly. So that's all. Thank you.